Hello again. Welcome to the sixth and final video in this statistical reasoning series. Today we will look at confidence intervals. So I want to read this little problem to you so that'll help us understand some of the things I'm going to introduce here shortly. So here's just a kind of random, typical, made-up survey, but something that you would see, it's very similar to something you could see in the paper. A telephone survey of 600 randomly selected people was conducted in an urban area. I mean, we could say in Regina. The survey determined that 76% of people from 18 to 34 years of age have a social networking account. So Twitter, Facebook, something, Instagram. The results are accurate within plus or minus 4 percent points 19 times out of 20. All right. With that, I want to introduce some terms. The first term that we should know when we're dealing with confidence intervals is margin of error. So what a margin of error is, it's the possible difference between the estimate of the value you're trying to determine from a sample and the true value of the population. So it's how much your answer could be wrong, long and short, okay? Now the margin of error is usually expressed as a plus or minus percent, okay? You've seen that before. In your example, I just pulled this back out of your example. Here's your example right here. We know that our margin of error would be right there, plus or minus 4 percent points. So I could do something like that, okay, to represent it a bit differently. So that is my margin of error, plus or minus 4. A confidence interval. A confidence interval is the range in which a polled or surveyed value is predicted to lie. So if you take a survey based on the information in the survey, you'll have a confidence interval. So it's where you think the answer lies. So back to our original problem, they're talking about social networking sites, what percentage of people actually have one. They gave an answer if they thought 76, but then they also gave you a margin of error of 4%. So they think it's going to be, 76% plus or minus 4%. That's where they're confident the answer is. So I hit my go forward there by accident. I could show that back to what we were just talking about with your margin of error. Simply what you have to do is you just go with your answer, which was 76, and then you would add 4% and you would subtract 4%. And you'd end up getting, I should say maybe, that'd be 80, this would be 72, and it would create a confidence interval of 72 to 80%. Okay, so sorry about me messing up my slide there, but that is how I would finish that confidence interval, okay? So you take your predicted answer and you apply your margin of error. A confidence level. A confidence level is the likelihood that the result for the true population lies within the range. So it's just how confident you are. So basically, how much money you'd bet on this, right? So if you're very confident, you'd bet a lot of money. If you weren't, you would not bet a lot of money. The confidence level for this telephone survey is 19 out of 20 or 95%. This means, well, first of all, they're super confident that this answer is right. Okay, so based on what they've done, they feel very confident. And now what that means is if they redid this survey 100 times, they feel that 95 times out of 100, the percent of the people in the population who have a social networking account would be between 72 and 80, meaning it would be in that confidence interval. It might not be exactly 76, but it's definitely in that confidence interval. All right, so we're just going to work with that. This is a pretty quick idea of what we're doing. We're not delving too deeply into this topic. First example. A 2010 poll determined that 65% of the people agreed that wind power should be used over hydropower. The results of the survey are accurate within 2.9 percent points 19 times out of 100. State the confidence level. Okay, so the confidence level. Remember, that is just how confident you are. So they're saying 19 times out of 20 or 95%. So they're saying they're very confident. By the way, you see a lot of repetitive answers with 90 or 95. They're never going to release a survey where they're like, 60%. No, we're not very confident this is actually true. They're always going to release things that they are very confident in. So that's their confidence level. 95%. B, determine the confidence interval. That is when we take our suggested answer, 65, and we apply our margin of error. So 65 minus 2.9, and then 65 plus 2.9. And that's how we are going to create this confidence interval. So 62.1 that ends up being. This would be 67.9. And it would create a confidence interval of 62.1% to 67.9%. So they are 95% certain that the actual answer is going to lie within here if it's not 65 exactly. Now, the population of Nunavut was 33,220 in 2010. State the range of the number of Nunavut residents who agreed that wind power should be used over hydropower for generating electricity. So based on B, we know the range is 62.1% of the people to 67.9% of the people. But we don't know the actual raw numbers, so if we apply the population of Nunavut, which we just talked about was 33,200, then we'll figure out the actual, like, what is 62.1% of that number, and then what is 67.9% of that number. So in case that's not making sense, let's just go through this. So I take my population, and I'm going to multiply by my percentage. Now remember, when you're multiplying by percent, you got to multiply by the decimal version of it. So I'm not going to multiply by 62.1. I'm going to multiply by 0.621. I divide that number by 100. And then that works out to be 20,629.6, which we'll just roughly round that. So 20,630. All right. So that is the low range of people in Nunavut. So we know that 20,630 are agreeing with this wind power. Now we got to figure out the high range, which is, we're multiplying by 67.9%. And again, we don't actually multiply by 67.9. We multiply by the decimal version of that, which would be 0.679. And that works out to 22,556.38. And again, I'm going to round that. So 22,557. I'm just rounding up, so I'm just going under. If there's more, a part of a person, we know there's more than 22,556, so I'm just going to bump it up to 57. And then from there, I can write this range of Nunavut residents who agree. So the range would be 20,630 people to 22,557 people. So we knew the percentage before, and now we have the actual number of people. So whenever you have to do that, just apply your percentage to that population, or the confidence interval, I should maybe say, to that population. All right, a second example. A fruit juice company takes a random sample to check the volume of cartons of juice. For a sample of 300 cartons, the mean volume is 1.1, with a margin of error of plus or minus 0.1 liters. The result is accurate 99% of the time, so they're very confident. Now, you may not have ever thought about that, but when you have a 1 liter carton of juice, there's a good chance it doesn't have 1 liter exactly, okay? They might give you more, because if you look here, the mean volume is actually more than that. So you might be thinking, why in the world would they give me more than they're actually like advertising? They're kind of like wasting money that way. Well, they got to give you more because they know that the machine might not be totally accurate. And if it shorts you some juice, they want to make sure that even a carton that is, slightly underfilled is still above that stated 1 liter. So that is why it's 1.1 in this example, so that even if you see the margin of error is plus or minus 0.1, even if it's a little bit less than the 1.1, it should still be a 1 or a little bit higher than 1 liter. Anyway, A. I kind of got off topic there talking about the juice industry, didn't I? A. State the confidence interval for the mean volume of the juice carton. So again, confidence interval is when you take your suggested answer. Okay, mean volume is 1.1. And you apply your margin of error. So I will subtract first. Then I will add second. So I end up getting 1 here, and then I get 1.2. So the confidence interval is, I guess, liter there. 1 liter to 1.2 liters. Okay, so they know that you could have up to 1.2 liters, again, because they're scared that they don't want to short you juice. They want to make sure you have at least 1 liter. Now, that's how I found that confidence interval. B, 3 other samples were taken using the same confidence level, but the margin of error for each sample was mixed up. in the report to the company's quality control department. Complete the table by matching the correct margin of error with each sample size. Okay, so for this I have to teach you something. That the greater the sample size, the smaller the margin of error. So the greater the sample size means the amount of things they're working with. So the more evidence they have, the better answer they can give, right? So things with a really high sample size can have a really small margin of error. Something with a very small sample size will have a larger margin of error because they just don't have the evidence to make a better answer. So looking at this, you can see here are sample sizes. Well, based on what I just told you, my largest sample size should have my smallest margin of error, so that should go with there. So the correct margin of error that's my mixed up one, so I'm just going to leave it like that for right now. My smallest then sample size should have my largest margin of error, and then you'll see that really that just means this middle-sized one should have the middle-sized margin of error. So now I'll write the correct ones out. So 500 we said should have the smallest, which is 0.05 plus or minus. 75 should have the largest, which is 0.2. And then the 150 should have the middle one, which is 0.15. So that is how margin of error and sample size are related. Final example. I'm telling you, this was a short one. Sports Goods produces tennis balls. The tennis balls have a mean diameter of 6.7 centimeters with a standard deviation of 0.05 centimeters. For quality control, tennis balls with a diameter in the range of 6.65 centimeters to 6.75 centimeters are acceptable. So meaning if there's something outside that range, they wouldn't accept it, and again, they'd get rid of it, or maybe they'd sell it off cheaply as something else. State the confidence interval. Okay, so this confidence interval is listed right here. That's the interval in which they're happy with, okay? So 6.65 to 6.75. Now, based on that, can we find the margin of error? Can you guys find the margin of error there? So what we can do, if you want to find the margin of error, simply find the difference in your confidence interval. So 6.75, subtract 6.65, which equals 0.10. And then divide that by 2. And then you get 0.05. And then what that'll tell you is that we know the margin of error is 0.05, meaning that my suggested answer, what their target really is 6.7 centimeters. And if I applied my margin of error, I'd get back to my confidence interval. And I can do that real quick if you'd like. So 6.7 minus 0.05, and then 6.7 plus 0.05. And what would I get? Well, in this one I'd get 6.65, and this one I'd get 6.75, and you can see that's exactly what my confidence interval is. So if you need to find that margin of error, find the difference in your confidence interval and divide it by 2. Okay guys, that is everything I have for you. So I hope that made sense. If it didn't, get talking to your teacher or get talking to me. Otherwise, have an awesome night.